This presentation is over the Jovian planet Jupiter and its moon, Europa. The contributors are Casey Stanford, Zachary DeLuey, and Melissa Peterson. Jupiter, the largest planet in our solar system, contains about 63 known moons in its gravitational field. 4 of the main moons surrounding Jupiter are Callisto, Ganymede, Io, and the infamous Europa. Europa is Jupiter's smallest major moon, but it is probably the most interesting of the 4. So you might ask, why Europa? Why are we making a big deal about a moon that is covered in ice? Well, Europa has secret facts hidden under the ice that could prove revolutionary. In order for a planetary body to be able to sustain life, it must contain a few things. It must contain some kind of an energy source, whether it be geothermal, geochemical, or gravitational heating by other moons or bodies. It must also have biologically significant chemicals. It has to have the essential components of life in its composition and atmosphere. It also has to have the capability of having water, not just any type of water, but liquid water. Liquid water is essential to any type of living being. Lucky for us, Europa contains all of these. Europa's tidal flexing provides heat energy for chemical reactions in the rocky interior. Another form of energy may be found in the seafloor volcanoes or hydrothermal vents. Europa also contains the biologically significant chemicals that are necessary for life. Europa is constantly bombarded by radiation from Jupiter, and this intense radiation can alter the chemistry of the icy surface, allowing the water below to be changed into chemicals needed to sustain life. Finally, liquid water is said to be found under the layer of ice on the surface of Europa. Europa is also said to have more water underneath its icy layer than the Earth has in all its oceans. So the next logical question would be, what do we plan to do while we are there? Well, NASA has a few goals in mind for the mission. 1. Characterize the extent of the ocean and its relation to the deeper interior. 2. Characterize the icy shell and any subsurface water, including their heterogeneity and the nature of surface ice-ocean exchange. 3. Determine global surface compositions and chemistry, especially as related to habitability. 4. Understanding the formation of surface features and identify candidate sites for future detailed exploration. And 5. Understanding Europa's space environment and interaction with the magnetosphere. There are some key facts to know about Europa. It has smooth surfaces and cracks. These are caused by the flexing of the moon's surface as it orbits Jupiter in an oval-shaped orbit. As the surface elongates towards Jupiter and then relaxes, the fractures open at the locations where the stress is the highest. And when these cracks are open, liquid water is squeezed to the surface and it forms ridges. Europa contains liquid water. The magnetometer on the Galileo spacecraft detected signs of an induced magnetic field near Europa's surface. The surface features of Europa suggest that there is a warm, mobile, glacier-like ice at relatively shallow depths that sometimes reach the surface. It helps explain the strange surface geography because the daily tides would cause the frozen surface to flex more. The pattern of the satellite's large-scale fractures shows that Europa may have slipped relative to the interior. A subsurface ocean would have facilitated this slipping and would allow the icy shell to slide over the fluid ocean. Europa also has vents that plume into space. Europa is thought to have the same active venting of water vapor that is seen on Enceladus. However, Europa is about 400 times more massive than Enceladus, and so the gravity of the satellite would prevent vented material from reaching more than a few tens of kilometers above the surface. The next question is, why go to Europa? Well, Europa has the best chance of finding life in our solar system. It is the only other place in the solar system where there is a very strong likelihood of finding liquid water. Atomic particles that are trapped in Jupiter's powerful magnetic field crash into Europa's icy surface with great energy, producing chemical compounds that could be used by living things. This provides a possible energy source that mimics the life-supporting energy of Earth's oxygen atmosphere. The life developed in a water environment. The evolution of life on Earth began in a water environment, and Europa would follow the same path. Europa contains the ingredients necessary for life. On future missions, there is hope for something to come in and drill into the surface of Europa and be able to understand its composition and see if there are any signs of life on the satellite. Learning about life in other places would help us understand life on Earth. If we find that there is life under the surface of Europa, we can learn how they have adapted and changed by learning how something could survive in such an environment as icy as the oceans of Europa. It would give us more information about how adaptation and how the organisms themselves live. Within the next 10 years, there is a plan to send an orbiter to Europa. The Clipper orbiter would orbit every 2 weeks for 45 orbits. The orbiter would do flybys to search for conditions suitable for life. The mission will contain a highly capable, radiation-tolerant spacecraft that would do the flybys from a looping orbit around Jupiter. The mission will carry a magnetometer to measure the strength and direction of the moon's magnetic field, which will allow scientists to determine the depth and salinity of its ocean. A thermal instrument will scour Europa's frozen surface in search of recent eruptions or warmer water, while other instruments will search for evidence of water and tiny particles in the moon's atmosphere. NASA has asked the European Space Agency to attach a lander or ice penetrator to the orbiter in order to better find signs of life on Europa.
This spacecraft would be designed to withstand intense amount of radiation. The spacecraft will be staying for the most part in an orbit around Jupiter. If the spacecraft was orbiting Europa, it would be bombarded by high amounts of radiation from Jupiter and eventually destroyed. One of the goals that astronomers are hoping to accomplish with this spacecraft is to measure the gravitational change of Europa by encountering it at different points in its orbit. By measuring it at different points in its orbit, this can help us obtain a global perspective of Europa. Part of the mission to Europa is about more than getting an overall view of the planet. It's about being 100% sure about what the planet is made of. This can be obtained through the lander or ice penetrator that NASA is asking to attach to the spacecraft being sent by the European Space Agency. The lander or ice penetrator would be able to take a sample of the surface and get to know what the composition of Europa is. Another important aspect to study is what has been collected through the Hubble Space Telescope. The Hubble Space Telescope has told us that Europa might be erupting plumes of water high into space. If this is true, we can control the spacecraft and send it through that plume, allowing it to sample whatever is being pushed into space. This will help us to create a clear image and idea of what the composition of Europa is most like. This will also help us to formulate some hypotheses about the subsurface ocean underneath the icy crust of Europa.